Welcome to the NXP Source Termination feature presentation. This presentation introduces the integrated source termination feature, its benefits, how it works, and the issues it solves. In addition, this presentation indicates the NXP logic devices and categories that have the source termination feature. Series termination is one of the many ways to terminate what are known as distributed systems. Electronic systems can be considered as either lumped systems or distributed systems. Factors that determine if a system is lumped or distributed include the rise time of applied signals and the delay time of the conductor. If all points on the conductor react to a potential at the same time, the system is lumped. Lumped systems have short trace lengths. If all points on a conductor do not react to a potential at the same time, the system is distributed. Distributed systems have longer trace lengths. Generally, the border between lumped and distributed systems occurs when the trace length exceeds the signal rise in picoseconds, divided by 6 times the delay time of the conductor, picoseconds per inch. Unlike lumped systems, distributed loads cannot be modeled using a single lumped capacitance. Transmission line models must be applied to determine the characteristic impedance of the distributed system. If left unterminated, reflections occur in distributed systems. This is due to impedance mismatch between the output and the load it's driving. Reflections can lead to ringing on the signals. Unterminated distributed systems can lead to signal integrity issues within applications. To avoid signal integrity issues, one common way of terminating distributed systems is source termination. In source termination, the output resistance of the driver is matched to the characteristic impedance of the distributed system. The matching is done by adding a series resistor, R sub S, between the driver output and the distributed load. The value of the series resistor is set to ZL minus Rout. ZL is the characteristic impedance of the distributed system, and Rout is the output resistance of the driver. Rout of the driver can be estimated using the DC characteristics found in the datasheet. The minimum output voltage, VOH, is specified under conditions of supply voltage VCC and output current IO. Ohm's law can be applied to determine the effective Rout equals VCC minus VOH divided by IO. NXP provides solutions in which output impedance matching is included. In general, the outputs are matched to a characteristic impedance of 50 ohms, making them suitable for a range of common PCB trace and cable impedances. While not providing perfect impedance matching for all loads, they can be used to reduce the amplitude of reflections in applications that are space-constrained. The undershoot and overshoot performance into distributed systems of characteristic impedance from 50 to 75 ohms is acceptable. NXP's advanced low-voltage BiCMOS LVT and ALVT families and advanced low-voltage CMOS families LVC, ALVC, and AVCM all include source termination as an option. Many of NXP's 8-bit, 16-bit, 32-bit products include source termination as an option. These include buffers, inverters, drivers, flip-flops, latches, register drivers, and transceivers. When source termination is included on a transceiver device, it is included on both ports. When source termination is included as an option within a family, a 2 is added after the family name in 8-bit devices. In 16-bit devices, such as the 74LVC 16244, the 2 is added after the 16. 16244 is changed to 16244 to indicate that the source termination feature is included. Source termination is an application-driven feature developed to replace resistors used in impedance matching of distributed systems. NXP offers a range of 8-bit, 16-bit, and 32-bit functions with source termination. These reduce bill of material and placement cost, as well as reducing the footprint of an application.